Thank you, Marco, for being with us today. And I'll just let you the floor for about an hour.
Okay. Okay, so good morning, bonjour, buongiorno, for those of you that know Italian. I'm glad to be virtually in Paris. I would have preferred to be there today, but maybe next year, hopefully, we will be out from this pandemic. So the session today is about different types of many-to-many relationships in Power BI. And my name is Marco Russo. I'm part of SQL BI, and I can see, let me see if I can, why we have this here, sorry, okay. SQL BI, we have a training material and other stuff about DAX and data modeling, which are technologies used in Power BI, analysis services, and Power Pivot. But these days, everyone is using Power BI. So let me see if I can remove this dialog that is coming up. Okay. So what we're doing today is we're going to talk about a new type of relationship that has been introduced in Power BI. Let's say, I would say 1 year ago, maybe more. But the problem is that the name of this kind of relationship can create some confusion. And the goal of the session is to basically cover the different types of many-to-many relationships we can have in a model so that we can understand when we can use the specific feature that has the same name in Power BI, when we cannot, and we have to use another kind of data modeling, depending on the type of data we have and the type of information we want to display. So this is the idea. The entire goal of the session is to make this comparison. So as I said, we have basically two types of many-to-many relationships. So clearly I assume for this session that you know Power BI, or you know the data model in Power BI, you know the relationships in Power BI, or in analysis services if you prefer. And we're talking about specific features. Now, I will spend most of the time in the demos, but at the beginning, I had to introduce some concept. And Power BI as a platform has three types of many-to-many relationships, which are highlighted here. So let me see if I can highlight this with a pen. So we have the one-to-one, many-to-many. Oops, I wanted to use this. The one-to-one cardinality, we have the one-to-many cardinality, we have the many-to-many cardinality. The many-to-many cardinality is the last one that it was introduced more than 2 years ago, almost 3 years ago, 2.5. And this is a name, as I said, that could create some confusion. Now, today we talk about two types of relationships that I'm going to highlight now. One is this one, the many-to-many relationship between dimensions. And the second one is the many-to-many cardinality, which implements a specific pattern that we could have implemented through a different technique. As you will see later, this many-to-many cardinality relationship is something we use to solve a data modeling problem when we have different granularities between tables we want to connect. Okay, so this is the entire goal of the session, and now I'm going to start talking about the first type of many-to-many relationships. Then we will see the second one. So the first type of many-to-many relationship is what we expect a many-to-many relationship to be when you talk in the business intelligence world, right? So these concepts have been discussed for, I would say, 30 years, maybe more, because it's not something new in terms of how to structure a data model in a relational database. I mean, this is a very old topic, right? And since when we started using dimensional modeling, which is a way to describe a data model specifically for analytics, where we define dimensions and fact tables that are tables that have different roles in the analysis, we always implies many-to-many relationship to be as a kind of relationship between two dimensions, between what we say, between two business entities. In a dimensional model, a dimension is a table, but this table has all the attributes of a specific business entity. For example, I have a company selling goods. I have customers, products, sales. A product, a customer, these are two business entities. A transaction where I sell some good is an event that describes the connection, the relationship between a product, a customer, and the time when this deal happened. So when we talk about many-to-many relationships, usually we discuss about an existing relationship between two dimensions that is not defined by one transaction. What does it mean? Think about bank accounts, which is the example we will see in a minute. When you have a bank account, there are transactions related to the bank account, but there could be multiple owners of the bank account. If you have a bank account and you are the only owner, easy. But a bank account can be owned by husband and wife, by brother and sister, by different directors in a company. So what happens when we have multiple customers? Because each customer can withdraw the entire amount of available in the bank account, which doesn't mean that a family made by husband and wife can withdraw the amount of the account twice. So we cannot duplicate the data when we have this kind of relationship. And if you think about the problem, let's say that we have customers. We discussed about this specific use case, the bank account. So we have customers, we have bank accounts. Now, a bank account usually is just a number, it's just a code. And we have somewhere the definition of the existing connections between customers and accounts. So each account has the list of the customers who can use that account. Now, usually this information in a relational database is not stored in the account table. In a database that follows the dimensional modeling guidelines, this information about the existing combinations between accounts and customers is an additional information that has to be stored in a third table. And we call this table a bridge table. A bridge because it acts as a bridge between the customer and the account. I go back this animation 1 second because I want to draw a line, right? So what we want to do, we want to say, okay, we want to connect the customer to the account. But as you see, we are not able to create this kind of connection if we don't have additional data. We need a table that has the list of the existing combinations between accounts and customers. Without this intermediate table, we are not able to say which customer can access which account. We need this information, right? Which means that, let me erase the ink here, which means that, okay, we have this information. With this information is in a table that is not a table that contains events. This is a table that just describes a state, the existing relationship between customer and account. And how do we connect these tables together? Well, the customer is connected to the accounts customer table through a one-to-many relationship, and the account table is connected to the account customers with a one-to-many relationship too. So this is the relationship between account and customer, between accounts and accounts customers table. This is the relationship between the customer and this intermediate table. Now, this intermediate table here is called a bridge table. It's a bridge between the two dimensions. But in order to create this structure, we need 3 tables, not 2. You are not able to create this relationship with 2 tables. You need 3 tables. You need the information that has to be stored in the bridge table. This information must come from the data source. Because if you don't have this information, you have no idea about how to connect customers and accounts, right? Now, even though we have, if you look at this slide, we have 3 tables and 2 relationships. But from a very high level point of view, we can say that the customer table, this table here, has, oh, sorry, I wanted to use the pen here. The customer table here has a many-to-many relationship with account table. At a very high level point of view, from a logical point of view, the customer entity has many accounts. One customer can have many accounts, multiple accounts. One account can have multiple customers, many-to-many. Which table defines this many-to-many relationship? The bridge table. This is the way it works, right? So we don't have a physical relationship that is called many-to-many, but we, as a humans, we say we have a many-to-many relationship between the 2 dimensions. Now, how do we define this relationship in Tabular? Tabular is the model we have in both Power BI and Analysis Services. Well, in Tabular, we have the ability to create exactly that kind of relationship, which means that we have the customer table. Sorry, I go back 1 second. We have exactly the same tables that we have seen before. And you see that this table, accounts customers, is our bridge table that has the combination between accounts and customers. We have accounts here, we have a customer here, and one-to-many, one-to-many. Now, where do we store the transactions? Where do we store the balance of the account? In a table. This is the fact table, in a table that is connected to the accounts table. So we have, when we have a transaction, we have a transaction for one bank account. But in case we want to create a report where we see some data, we might want to group the data not by account, but by customer. What does it mean? Let's go to this model. And before I describe the report, let's take a look at the diagram here. So you see that we have basically, we have the same tables we have seen in the slide. This is a real model. We have customers, we have accounts customer, we have accounts, we have transactions. If we take a look at the content of these tables, we have this. We have for the customer table, we have 4 customers. For the accounts table, we have just a few numbers. Or in this case, just to make it easier to understand what we're doing, we replace these numbers with the names of the owners of the account, which means that Mark Robert is just a string. Instead of looking at 5, we see Mark Robert, but we know that Mark Robert is just a string. So when we go in the report, we would like to see what? Let's remove this for a moment here. We want to see this. We want to see a list of the customers, and for each customer, I would like to see the sum of the amount we have in the transactions of all the accounts of the customer. Now, as you see, this is not working. Let me duplicate this, because so far we didn't create anything particular. So we, okay, copy and paste, come on. Okay, so if I duplicate this visual, you see that I can replace, let's see if I can, okay, I can replace here the customer with the account. Here we go. And you see that the account works. I mean, Luke has 500, Paul has 2,000, Robert has 3,000. Mark Paul, which is an account owned by both Mark and Paul, has 500. Now, if you look at this table, you can say that Mark should have 1,500. But why we see 8,000? Well, we see 8,000 because at this point, the way it works, the way Power BI works, when I filter a customer, for example, Marco filters accounts customers. So you see that the relationship has this arrow which identifies the filter propagation direction. So customer filters accounts customers. But once I filter the table accounts customer, I'm not filtering the accounts. Let's go back to the slide. So when we filter customer, the filter propagates here. So let's remove the ink here. Okay. Right, so we had the filter automatically moves from the customer table to the bridge table, but then the filter does not propagate to accounts. This is not happening. Why? Because by default, the filter propagates from accounts to accounts customers, one-to-many. So far, I didn't introduce a new type of relationship. I'm just introducing a problem, which is the filter propagation between tables using an existing one-to-many relationship. So how do we solve this problem in Power BI? Well, we have different options. We can change the cross-filter direction of the relationship. What does it mean? If I go back to Power BI and I double-click this relationship, you see that this relationship shows that the cross-filter direction is single. Well, if I change this cross-filter direction to both, I'm creating a bi-directional filter between accounts and accounts customers. What does it mean? It means that if anything is filtering accounts customers, the filter will propagate to accounts. Today, before doing that, it's only accounts that filters accounts customers, because the filter always propagates from one to many. Now we're saying I want to propagate the filter from many to one and not only from one to many, which means that when I click OK, you see that now this is a double arrow, so I propagate the filter both directions. Now, when I enable this, what happens is that customer filters accounts customers filters accounts, and accounts filters transaction, because again, we have this propagation. For this specific report, if I go back here, now my report is working, and you see that mark is 1,500, which is the sum of these three accounts. And by the way, if I include the account here in a matrix, I can actually drill down and see that mark is made by these three accounts. And if I click here for Paul, I see that Paul has two accounts. And by the way, please notice that if you look at the grand total is 8,000. If you look at the grand total here is 8,002. Wait a minute, this means that if the sum of the accounts is 8,000, how is it possible that the sum of the customers is 8,000? It is not. This is still the sum of the amount of the accounts, where every account is counted only once. If you sum Robert, Paul, Mark, and Luke, you can see that you should obtain something that is way higher than 8,000. But we see 8,000 because in 8,000, Mark Paul and Mark Paul is counted only once. Mark is counted only once, but Mark Robert is counted only once. So we see 8,000, not 9,000, because we count every account total only once, right? Which means that whenever you have a bidirectional filter enabled in your model, you have a non-additive calculation introduced in your model, which can have several side effects. First, it impacts performance. It's harder to use any kind of caching of the data when you have this relationship enabled. Second, the result could be affected by the presence of this bidirectional filter, even though you don't expect that. Now we enable this bidirectional filter because we wanted to see a number here computed the right way. But actually, if I create other measures, if I import other tables, I could have an undesired side effect because of the presence of this relationship that now is always active for any kind of calculation. So even though we like the ability for the engine to apply this bidirectional filter and automatically get the result we expect, it's a best practice to not enable this bidirectional filter in the model. But it's a best practice to enable this bidirectional filter only in specific calculations we want to obtain, enabling this, but for specific formulas. For example, here I can create, so you see that now if I go back here, because I disabled that, you see that the number is always 8,000 here, because of course I'm not propagating the filter, so I'm not filtering any account by the customer. But if I create a measure, sum of amount here, right? So if I use sum of amount, it's just the sum of the column before I used an implicit measure. Now I include this measure here. Sorry, I already have this measure here. Okay, yes. So what I can do here, I can say, okay, I want to calculate this measure, but I want to enable, just for this calculation, I want to enable the bidirectional filter between, so I use cross filter, I want to enable the bidirectional filter between accounts, account and accounts customers account, and this relationship has to be bidirectional. Now actually it's a best practice when you use cross filter. I mean, it's the same thing, but it's a good idea to always put the many side of the relationship in the first position, just as a convention, because usually it's easier to read the code when you have complex formulas. But actually you can invert the position of these two columns and the result will be the same. Now, when I click enter, see what happens. When I validate this, now the measures I have here are again those that we have seen when I enabled the bidirectional filter in the model. But now I'm enabling the bidirectional filter only for this measure, and I don't have any side effect on other measures. So other measure will be fast as before and will not have different results just because I'm filtering one customer. Okay, so we go back to the slides just to recap what we have seen so far. So we have seen that I can use the model, I can enable the filter in the model, or I can do that in Calculate. And please pay attention, in performance, from a performance point of view, using cross filter or using the bidirectional filter enabled in the model is the same. No performance penalties if you use Calculate this way. So don't worry, this is the right thing to do because you don't want to manage the side effects that you might have later. Okay, so recap. So far we have seen, and I go back here, we have seen a logical many-to-many relationship between dimensions. In this case, we created a relationship between accounts and customers from a logical point of view using a bridge table defining the existing correspondence between two business entities. They don't have any measure attached to it. The measure is on another fact table. Now we have another data modeling problem which is completely different. And the problem is the following. Sometime in a model, we have dimensions, we have fact tables, but we need to connect two tables, and typically a dimension and a fact table, using a column that is not unique in the dimension. So basically we say that we want to connect a dimension to a fact table, but the fact table doesn't have data at the right granularity. What does it mean? Well, a typical example of this problem, and again, this is an example, but this is not limited to this example, the problem I want to show you, but a typical example is the following one. From one side in this slide, we have a classical star schema. What does it mean? We have here this area of the animation is not what I wanted to use. Let me go back 1 second. Let's see if I can use the pen here. Just showing this. So customer, product, and date are 3 dimensions connected to sales. The sales is our fact table. These 3 dimensions and 1 fact table form a star schema. Now, this is a typical sales star schema, but then we import another table, budget. Now, if you look at the model with the sales, every transaction has 1 date, 1 customer, 1 product. And you see that the customer and the product are identified by customer key and product key. The product key and the customer key columns, like the date column in the date table, are unique columns, are columns that have 1 unique value for each row in the corresponding tables. They are primary keys in a relational database. But the budget is unlikely built based on customers and products. It's more likely that we have a budget by country, including all the customers of that country. And it's made by brand or by product category, which is a group of products, and is made by month, which is a group of dates. So we have a cardinality issue here, because yes, we would like to compare the budget with the sales. But in order to do that, we need to connect both budget and sales to the same dimensions. Because if you want to create a chart in Power BI where you use a measure for the sales, a measure for the budget, and you want to see this by brand or by country, you need to share the same table between the two budget and sales fact table. You need to share the same dimension. So my problem here, I want to create a connection between customer and budget. I need to create this relationship. And I need to create another relationship between product and budget. And I want to propagate the filter in one way only, right? My filter should propagate from customer to budget or from product to budget. But I cannot create a classical one-to-many relationship. Why? Because if you look at the content of these tables, the country region table has, sorry, I have to click here. The country region, sorry, the budget table has country region, which is basically the country to identify the customer. And this country region is a column here, but is not the customer key. We have multiple customers for each country. So we are not able to connect customer to budget using a one-to-many relationship. Okay, so this is the problem. So we have a logical relationship between these two tables based on country region, and the same happens between product and budget. Product and budget can be connected through the brand column. But again, these columns are not unique in the dimension, so they cannot be used in a classical one-to-many relationship. Imagine that. In a relational database in SQL Server, you cannot create a foreign key relationship between budget and customer or between budget and product because those columns are not unique identifiers in customer and product. So what are the options we have? First of all, let's go to the model. And here, so this is the same model we have seen in the slide. At the moment, I didn't create any connection between customer, budget, and product. And if I go here, you see that I have here sales that is working. You see that here I have brand and I have color. And I have the budget here, which is just the sum of all the rows with the budget. So basically, the brand is not filtering the budget. And the budget column that you see here is just the sum of the budget column. This is called an implicit measure. We don't have a real measure at the moment. We just have a column with a simple sum, aggregation sum. Okay, so what options do we have here? So let's go back to the slides 1 second and let's move forward. So if you think about the problem, we have just a problem of propagating a relationship because we need to propagate a filter between product and budget using the brand. In this particular report, let's go back to the report. I know that Contoso is a column that I have in budget. If I go to the budget table, budget here, if I filter the brand here and I say I want to see only Contoso, right? This is just a preview of the data here. What I really want to do, I just want to sum this column for these rows. That's it. And how can I do that in DAX? Well, I can create a measure to do that. If I go here and I say, okay, I want to create a new measure, I create a measure my budget. Let's enlarge this a little bit so it's easier to read, which will be a calculate statement where I have the sum of the budget. But here I want to apply a filter. And how can I apply a filter? Well, we have different techniques in DAX, and a modern one is using treat as, where I can give me the values that are currently filtered in product budget, in product brand, sorry, brand. So I go here, I want to get the values in product brand, and I want to apply them as a filter to budget brand, this way, right? If I do that, I click enter. Now I have a measure here. Let's just format this measure as a decimal, and then move this measure here in the report. with 2 decimal points, so we can see the same number with the same representation. Okay, so let's go here and let's close this. You see that now my budget is working, and it is working even though for example, here I have a scenario, which is another, we have 3 different budgets, 3 different scenarios for the budget. If I click on high, this is working. If you click on low, this is working. So it's working, and it is using my selection in the brand here. Now, can I do something leveraging the model, leveraging the structure of the model instead of relying on the measure that I created? Well, yes, I can. So I go back to the slide 1 second, because what we did now, we used 3 tags. Of course, because I have 2 tables, I should use 3 tags for each of the 2 dimensions. And another way in DAX to obtain the same result, instead of using 3 tags, you could use in. You can write column in values. Same thing. You just invert the order, but basically it's just a different way to move the filter. Because basically in DAX we can move filters using DAX. It's just a programming language that allows us to move filters around. What's the problem with that? Well, the only problem is that performance. Performance, and maybe you have to duplicate this code in every measure. Could be boring, right? But the main issue is performance. The performance we obtain with the technique that I've shown you is the worst we can have between those other techniques I will show you. So can we solve the problem from a data modeling point of view? Well, yes, why not? Think about this. If I go back to my model, I can say, wait a minute. If I didn't have, so let's highlight this a little bit. So let's consider just product and budget. How can I connect product and budget so that using just one-to-many relationship, they are connected together? Well, if I had a list of brands, because the problem is that I cannot create a relationship if I don't have a table that has 1 row for each brand. So I can create a table like that. I can create a table that has the list of the brands. Let me do that. If I go here and I say, okay, I create a new table, brands, and brands, I can create a calculated table that basically retrieves the unique value from the brand column of the product table, right? I do this. Why not? You see, I have 1 row for each brand. Then I go back here and I move this table. Let's just move this table here. Okay. Then I will increase the size again. Okay. Now I can do this brand and I can do this brand. Now, is this a column I want to show to the user? No, I don't want to show this column to the user. I mean, I could, if I show this column to the user, it just works. If I remove the brand column from this visualization, right? I have only the measures here, and now I use the brand column from the brands table here. It just worked. My budget implicit measure is now working. So why we don't use this technique? Well, many business users will be scared about seeing the brand so many times. So we could hide a brand here so that the user would not see the brand here. But having the brand in the product table and having the brand in the brands table could be not ideal. If you hide the brand column in the product table, you will end up having the attributes of the same business entity, the product, scattered in different tables. So if we had a way to create a logical model, putting together columns from different tables, that would not have been an issue. But because we don't have that option in Power BI, we would like to keep all the attributes of the product within the product table. So what we would like to do, we would like to hide the brands table so that the user is not getting confused. But if I do that, how can I make this brand selection working using the table brands that we use now? Well, actually, I have an option. Now, because this table is hidden, and because my real goal is to filter budget using the filters applied to product, I want the product to filter budget, not the other way around, which is something I can obtain automatically by enabling the bidirectional filter here. Now, we always say, don't enable bidirectional filters. But in this case, it's absolutely safe to do.
Marco, I can't hear your mic anymore.
Can you hear me?
Yes.
Okay, sorry. For some reason, it was muted. Okay. So I was saying, so what we want to do, we want to filter, we want to propagate the filter from product to budget. And sorry, I'm not sharing the screen too. So wait a minute. Can you see? Oh no, you see my screen. Okay, okay.
Yes.
So we want the product table has to filter budget. We don't want budget to filter product, so the filter has to go one direction from product to budget. But this bidirectional filter is actually allowing me to do that, because if you ignore brand, what happens is that when you filter product, you filter budget. But when you filter budget, you don't filter products. So this is an artifact, two relationships, and this table in the middle is a technical way to obtain a single direction relationship between product and budget using a different granularity. So what we're doing is we are propagating the filter between two tables using a single direction filter working at a different granularity. Okay, this is what we're doing. And it works, and it works well. And it is safe to keep the bidirectional filter here in this model. Absolutely safe. This was possible since 2006, since when we had the bidirectional filters. However, in October 2018, Microsoft added a feature that allow us to do this. So I removed this table in the middle. I removed the two relationships. I just get the brand here and I connect the brand here. But pay attention. Now, I can create a relationship using these two different columns at two different levels, but the default option provided me is always wrong. We don't want a bidirectional filter here. We want product that filters budget, not the other way around. Because if we enable a bidirectional filter, again, we have a ambiguity in the model that will create a lot of problems. But this is not creating any problem. It is just not the default, right? We have to always provide what is the right direction. If I do that, we have this relationship that says, okay, I'm connecting brand to brand, and I'm filtering the budget table using the filter that is available in product. What you get with this is identical to the previous definition in terms of what you get as a result. Okay, so the result you obtain with this technique is identical to the result that you obtain with the two relationships and the intermediate table that we obtain from the model. Because remember that the brands table was built using something we already had in the model. We didn't have to import new data. We just used the calculated table, so we already had the information. In terms of performance, the faster technique is the previous one. Even though you might think, oh, wait a minute, this is a single element in the model that it should be faster, right? No. So in reality, it depends on how many brands you have, how many unique values you have in this relationship. When this number is around 10, 20, 100, the performance difference is so small that we can ignore it. And we can basically say, okay, that's fine. But when you start having hundreds or thousands of unique values in this column, believe me, you want to use the other technique. Yes, you need a little bit more time, but it is faster. Try it if you don't believe me and measure your performance. So clearly, because I have only 10 brands and a few countries, okay, that's fine. I use it. No problems, because this this makes me more productive. But when I want to optimize the performance, I know that I might want to change this. Now, this relationship is called a many-to-many cardinality relationship. But a many-to-many cardinality relationship is not what we were used to call a many-to-many relationship between dimensions in business intelligence. And the reason can be recapped in these slides that I'm going to show you now. So we said, I created the relationship between product and budget and between customer and budget using a table that I obtained from the data that I already have in my model. So country regions is just a list of the unique regions we have, the unique countries we have in the customer table. Same for brands, we have the unique brands in the product. Then we could obtain these tables also using these calculated tables. I used the shorter version because I just used the brand from the product. But if you think for a second, you might have brands in the budget table that are not described in the product. So you may want to include them, even though this will not solve all the problems from other point of view. But at least by doing that, we will have at least a complete list of brands in case of. And we are using distinct, or if you want, you can use all no blank row, because if you use all or values, you could obtain a circular dependency you don't want to see in your model. So the bidirectional filter we created here in this relationship, we created a bidirectional filter because this was the technique to propagate the filter from product to budget, right? This is what we used. And the other technique is to use this many-to-many cardinality relationship where we have a single direction filter between the two relations, the two tables. The result is the same. The performance is slower, but for a small number of unique values, that's fine. So what did we see? Let's see if I can remove this. Where is my mouse? Okay. So here and here. Okay. So we have the entire slides of it. So let's recap. What did we do here? We created a many-to-many cardinality in our relationship, which means that we had a list of products, we have the budget, but the budget was based on an attribute of the product. What is this adventure works you see here? Adventure works here. Well, adventure works is something that we have in another column of the product table. But because the same adventure works is present here, here, and here, maybe, what we want to do, we want to have a table in the middle that we created with a unique, the list of unique values of the brands. And then we created a one-to-many relationship between brands and product and brands and budget and brands and product. By using this technique, we created a high-level relationship, which is a many-to-many cardinality relationship, which is what you can get with a single step in Power BI. But at this point, let's try to analyze the differences between the different types of many-to-many relationship we have seen today. In the classical many-to-many relationship between dimensions that you will see in every book about dimensional modeling since 40 years ago, when it is written many-to-many, the author was saying this, which means I have two relationships in this sequence, one-to-many, many-to-one. Or you can go the other way around, one-to-many, many-to-one, same thing, right? So one, many, many, one is what we call a many-to-many relationship between dimensions. It requires a bridge table. The bridge table has data coming from the data source. If you don't have this third table, you cannot create this relationship at all. But then we have another situation where we have a relationship at different granularities. When we want to connect the product to the budget, then we need a table that has only the unique values of the brands. But this table has been obtained extracting data from an attribute So we obtained this as a calculated table. Did we import an additional table from the data source? No. We already had this information. We just created a table to get this information in a way that was more model friendly with our set of one-to-many relationships. But now, if you look at the relationship existing from product to budget, what you see is that if you follow the relationships, the sequence is many one, one many, or many one, one many, right? Many one many is a many-to-many cardinality relationship based on data you already have in the model, and it is usually a way to transfer a filter between tables at different cardinalities. When you have one many one, you are doing a many-to-many relationship between dimensions using an information coming from the data source. Without that, you will not be able to establish the relationships between the dimensions. Now, whatever you do, you need a single direction. Yes, we have seen that we can obtain this single direction between product and budget using the bidirectional filter in one of the two relationships in the model where we used one-to-many relationship. The reason why this technique is faster than the other one, using a single logical relationship in the Power BI model, is because the one-to-many relationship is the only one materializing indexes to improve the performance of the relationship. When you have a many-to-many cardinality relationship in Power BI, you have something that is faster than doing the same using 3 tags in DAX, but it is still something that the formula engine is doing. There is no help from the storage engine to support that kind of relationship. And this is the reason of the performance difference. So recap, and then I'm open to your questions. We have seen that we have two different types of many-to-many relationships. When we see one many one, we have a bridge table in the middle with data coming from the data source. When you have many one many, or a single many-to-many cardinality relationship in Power BI, the bridge table in reality is just a normalized attribute. We copied in a table just to enable the creation of the physical relationship. There is no additional data. It's something similar to a snowflake schema for those of you that come from a Kimball dimensional modeling background. And today in Power BI now, since 2 years ago in Power BI, can be implemented with a single many-to-many cardinality relationship, which is good if the relationship has a small number of unique values. Questions?
Thanks a lot, Marco. That was pretty high level and dense. I mean, a lot of things and coming in ahead. I read a question from Camille, who was asking if you could expand a bit on the side effects of using a bidirectional filter on a one-to-many relationship.
Okay. Let me help because we don't have much time. So I just want to show you an article so that you can see more about that. So I think is this one or this one, or I think the first one, this one. Okay, I'm showing you here. Oh, wait a minute. This is the
That's
video.
someone we know.
Okay, sorry guys. So if you go here, bidirectional relationships and ambiguity in DAX, this is a complete and longer explanation of the problem, right? It's similar to what we have seen today, but it goes deeper and explain why this could be a problem, mainly because of the uncertainty it introduces in the number. Because of course, the performance is a big issue, but believe me, what you don't want to deal with is the fact that you might have wrong numbers in your reports. It's easy to get things out of control when you start doing something like that, especially when you have other relationships, like in this case. This is a classical case where you don't want to do this at all, right? Because it's too dangerous, it's too complex, and with just 5 tables, you will see in the demo, it's almost impossible to understand what's the meaning of the measure that you will get from purchases, right? Because, you know, what you have is that the date table will filter sales and filter the result of customer and sales propagated to product, getting numbers in purchases that you probably don't even understand. And so that's the biggest danger. If you ignore this problem because you say, okay, my model is smaller, the only problem you have, bad performance. Because you introduce something that in every measure injects something that you might want not to have. And so the real question is, why are you enabling this? Because if you're enabling this for a calculation problem that you have, is fine, but you should be able to move this into the measure. And so you localize the performance penalty only in that measure. If you do that because, oh, but my slicer are not, you know, are not reduced by only showing the values that I can see with the data that I select in other slicers. Oh, there is another way to do that. I think we have the link here. Maybe not here, but you can enable, let me check, a filter measure slicer secret BI. Let's see if this is this one. So if you have this problem, you can see what we describe here, which is, okay, I want to reduce the list of the values in a slicer. So instead of enabling the bidirectional filter, you can just use a measure in the filters for the slicer, so that you specify what you want to hide and why and when. You have more control this way, by the way, and performance is much better. So if you experience bad performance in your model because of that, you will find a lot of solutions in these two articles. So I go back here, you can copy the link or the title. Okay?
Okay, we have two more
Yep.
that just popped up. Could we basically say that when the bidirectional cross filter is needed for some specific uses, that the go-to way is to create dedicated measure using the cross filter DAX function?
By default, yes. The only case where it is safe to enable the bidirectional filter is, let's go back here, is this one. So if you remember what I did before, I created, let's go to the slide, it's simpler. So I think, oh, where is the slide here? This one. In this case, it is safe. And why it is safe? Because if the brands table is hidden to the user, right, and you don't connect other tables to brands, then you are just creating an artifact to propagate the filter in a single direction between product and budget. So remember, the problem is not the bidirectional filter by itself. It's only for the performance. The problem is that the way we propagate the filter between dimensions is the real problem. And when you have a bidirectional filter between two tables that are exposed to the user, you end up having a ambiguity problem when you have certain measures or certain complex model that we will see in the article, and you don't want to do that. Now, this is a safe case, but again, what I suggest, before enabling the bidirectional filter, you have to say to yourself, can I write an email to Marco explaining why I'm doing this, because he will approve me. If you're not able to write an email, you certainly don't have a good reason. If you can write an email, probably you have a good reason. If you're not able to explain why you really need that, you need a strong argument. You have to demonstrate, I have no other way to do that. Okay, that's fine. But as I said, if the reason is that I just want my slicer to work in a nicer way, okay, there is another technique to do that. Don't use the bidirectional. 90% of the times we see the bidirectional filters enabled for the wrong reasons. And this creates a lot of performance issues and sometimes also bad numbers. So try to avoid this problem.
And the last one from Frederick.
Yep.
Why many-to-many Power BI weak relationships with both filtering can sometimes be activated, even if they create logical multiple path or filter between tables. Is it apprehended by formula engine within the query?
Before answering the question, I have to explain the question to the people who may not. When you create So first of all, a weak relationship, now Microsoft called them limited relationship, is a relationship that doesn't enforce the blank row on the one side of the relationship. So every time you have a many-to-many cardinality relationship, or you have a relationship crossing the boundaries between two data sources, we have what we call a weak relationship. The weak relationship by itself is not an issue for creating ambiguities. I think that the bidirectional filter could be an issue. When you have a bidirectional filter, the algorithm in DAX always try to solve the ambiguity, but certain level of ambiguities are not allowed in the model. So what I'm saying is that you can enable, using cross filter, ambiguous scenarios that are not allowed to be enabled in the model. And this is the question. So why can I do that in the code and not in the model? Well, because if you start doing that, it's supposed that you know what you're doing. But the real issue is that as of today, we don't have a documentation, an official documentation about how the ambiguities are solved by the engine. Which means that as of today, in a situation like the one that you described, nobody can guarantee that the behavior that you obtain is the one that you will obtain tomorrow. So I would say pay attention to these things. Don't put yourself in a place where you don't want to be. So no, there is no automatic understanding from the formula engine. It's just that there are rules that are applied, and these rules are not disclosed publicly. And it's an embarrassing situation. We would like to write these rules. We don't know them at all. So we know how it works at a very high level, but there are many side cases, corner cases that are not well understood also by us. So it's hard to, if we cannot write the article, how can we do? And we hope that one day Microsoft will provide a clear, documentation about that. Okay.
All right. Well, that's all, and we are right on time. Congratulations.
Right. Great.
And thanks again for this this awesome presentation. That was very enlightening. Right.
Thank you very much.
Yep. We'll see you on the cafe, and have a great, nice rest of your day. Bye-bye.
Okay. Bye-bye. See you. Bye-bye.